This video is about dividing polynomials using long division and synthetic division. Alright, so this is our first example. It says divide this polynomial by the second polynomial. And if you think about long division, the first thing we'll learn is long division. And if you think about long division, when you first learn long division, you learn stuff like 3 divided into 7. And you ask yourself, okay, how do you divide 3 into 7? You ask yourself, how many times you have to multiply 3 by a number to get close as you can to 7? You're like, well, you have to probably think, okay, 2. And 2 times the 3 will give you 6. And then you subtract. Then you get 7, subtract 6, you get 1. And then, because 3 couldn't go into 1, you would start off by saying remainder 1. So you would say 3 divided into 7 equals 2, remainder 1. It's probably the first way you wrote it. So that's how you first learn how to actually do those. So that's what we're going to talk about today. We're using long division to actually simplify polynomials. So if I'm looking at this one and I want to divide it by x squared, subtract 2x plus 2, I would take that outside. Well, I'm going to need this space. So I'm going to erase all of this stuff so I can use this space. All right, so I'm going to write it up as long division with the polynomial that's the denominator here and the numerator underneath the division symbol. So the first thing action is, what should I multiply this first number by to get this first number? So x squared times what is going to give you 2x to the first. So you might think, okay, well, 2x squared. So 2x squared times x squared will give you 2x to the fourth. But after you distribute to the first number, you have to distribute every number here, right? So you got to distribute to the first one, the next one, and the next one. So then you ask, well, 2x times negative 2x, or 2x squared times negative 2x. So that's negative 4x to the third, and then 2x squared times 2. Well, that's going to be positive 4x squared. You might notice that 5x and 4x squared doesn't really line up, so you can't add those. So next thing you're going to do is, if you remember long division, the next thing you had to do was you change the sign. So all this signs change. So you got to subtract them all. So 2x to the fourth, subtract 2x squared, cancels. And then you have 3x squared. Now this is plus. So this is going to add up before x to the third. 3x to the third plus 4x to the third is 7x to the third. And then these two don't combine, so I'm going to bring them both down. So subtract 4x squared plus 5x. And then the 1 on the end, I'm going to bring that down. So now we got a new line. And I'm going to ask myself, what should I multiply x squared by to get the first number here now? Right? So x squared times what gives you 7x to the third. So I would know that's 7x. If you have trouble figuring that out, what you could do is take this number and take this number and divide them. If you have trouble figuring out what those numbers are, you could say, well, 7x to the third divided by x squared. What is that? And you might think, well, 7x to the third means 7x, x, x. And x squared means x times x. So a bunch of stuff cancels. These cancel, those cancel, leaves you with 7x. So you know what the number has to be. So that's if you can't figure it out just by looking at it. So I just divide the numbers. So going on. So 7x got to distribute to each one of these numbers. The first one, to the second one, and to the third one. So 7x times 2x, x squared is 7x to the third. 7x times negative 2x is negative 14x squared. 7x times 2 is 14x. All right, so again, from there, you got to change everybody's sign. So this changes, and that changes. Well, not everybody, just the bottom row. So when you combine these, they cancel to be 0. And 4x squared plus 14x is 10x squared. And then 5x subtract 14x is negative 9x. subtract 1. Next up, maxing now, x squared times what is 10x, right? So that's pretty easy. That's just 10. So multiply 10 to all those numbers. It's kind of hard to write all the way across, so you just visualize 10 times each of those. Should be 10x squared, and then 10 times the negative 2x is negative 20x, and then 10 times the 2 is plus 20. All right, and then you got to change everybody's sign. Subtract, that becomes plus, that becomes subtract. All right, so these cancel. These combine to be 11x. And these combine to be negative 21x, or negative 21. All right, then x up. X squared times what is x? 11x. Well, you can't make x squared reduce to 11x. So this is your remainder. So the remainder is 11x subtract 21. So our answer is this top part and the remainder. So you want to know what that would be if we divided them. The answer is, I'll write it here. The answer is it's actually called the quotient, not the solution. So the quotient is 2x squared plus 7x plus 10, remainder 11x, subtract 21. Now you can write this remainder other ways. Another way you could write the remainder is, you could have called it 2x squared plus 7x plus 10. The other way you write the remainder is, if you remember from long division, you could take the remainder and put it over what you divided by. So it should be 11x subtract 21 over x squared subtract 2x plus 2. So you could have wrote it this way. So you can see it this way, or you can see it the bottom way as an added fraction to it, and that fraction is remainder over what was on the bottom of the fraction, or what you divided by. All right, so anyway, that's how you use long division. It's a lot of information. I'm going to give you another one to try on your own tonight's homework, but I got another example to give. I got a new example. It says divide this polynomial by that one. So right now, pause the video and actually divide this using long division. And see if you get the same answer I have. So pause the video, give it a shot on your own, and divide it using long division. So go do so now. All right, if you paused it, and you tried it out on your own, instead of me just giving you the answer and showing you how to do it long division again, I'm going to let you check your answer to mine, and I'm going to do it with synthetic division. All right, so with synthetic division, you want to find k. And how do you find k? You find k by, all right, so you find k by setting the denominator equal to 0. So the denominator is x plus 2, so put x plus 2 equals 0. Subtract 2, x is negative 2. If x is negative 2, then k is negative 2, and that's the number we want. So just so you know, in synthetic division, it works like this. You need a synthetic division bracket. And that's the synthetic division bracket. Here is k. K in our problem is the number 2. Here, you place the coefficients of the numerator. So you want these coefficients, but make sure the coefficients are going in descending order, as in the exponent goes cubed, squared to the first constant. If it skips numbers like cubed and it skips this one and it's not there, and you got like to the first and constant, any of those ones that are missing, you got to plug in zeros as placeholders. This doesn't miss anything, so we use all our coefficients and constants like they are. So the numbers are 1, 2, negative 6, and negative 9. And how synthetic division works is this. Basically, you take the first number, it comes straight down, 1. And then I take the number k, and you multiply by the number on the bottom here. 2 times 1, which is 2. these add together. So 2 plus 2 gives you the 4. And then after I get this number on the bottom, I take this number k again and multiply by the new number on the bottom. 2 times 4 is 8. Add these up. Negative 6 and 8 is 2. And then whatever's there gets multiplied by k. So 2 times 2 is 4. Negative 9 plus 4 is negative 5. And that's the last number in the list. So this last number is my remainder. And when I write my polynomial, it works like this. If I begin as x cubed, this number 1 is a coefficient of x squared. So that always drops one number. So this starts off as 1x squared plus 4x plus 2, remainder negative 5. Or you can call it 1x squared plus 4x plus 2 plus negative 5 over what you divided by, x plus 2. So plus sign. Alright, so those are two ways you can represent the answer, or the quotient rather. And that's what you should have got had you did this problem with long division earlier. You should have got this remainder of negative 5. Alright. Well, no, I'm about to erase all this, so you need a note, I'll copy it. Alright, this is a note. Note is a polynomial f of x has a factor x subtract k if and only if f of k equals 0. Alright, this is essentially the remainder theorem, which I'm about to explain now. But this is a fact. I'll write it down someplace. It's nice to know. It comes up a lot in this unit. But that's true. Alright, I'm about to erase this screen. Alright, this is the example. Is x subtract 2 a factor of this polynomial? Considering the last note, if that's true, then if x subtract 2 is a factor, then f of 2 equals 0, if it is a factor. So the question is, does f of 2 equal 0? So what we can find out is we can plug in 2 for all these numbers. So f of 2 is going to be 2 to the third, subtract 2 times 2 squared, subtract 9 times 2 plus 18. I'm going to plug that directly in my calculator, just as it says. 8 subtract 8 subtract 18 plus 18. That's 0. So f of 2 is 0. So x subtract 2 is a factor. So that's how I can prove it's a factor. If I could plug in 2 for all the x's and get 0, that means it must be a factor. Now, if that's a factor, just thinking about this, if that is a factor, what does that mean as a factor of it? If that's a factor of it, that means I could divide this polynomial, x cubed, subtract 2x squared, subtract 9x plus 18 by x subtract 2 evenly. Alright, and it didn't have a remainder. So we think about factoring by grouping. This is probably factored by grouping. If I look at these numbers, I think I could tell that's going to be factored by grouping. So right now, pause the video and factor the numerator by grouping. Pause it. And if you just did that, you should have got x squared, and then x subtract 2, subtract 9, and then x subtract 2, over x subtract 2, which gives you x squared subtract 9 over x subtract 2 over x subtract 2. And you notice that both of these x subtract 2's are going to cancel. So x subtract 2 is a factor because it's x subtract 2 times x subtract 9 squared. So that together will give you back what we began with. So yeah, it is a factor. If I divide it by, they do cancel out, give you x squared subtract 9. So it does divide into it evenly. So that's just another way to think about it. All right, anyway, that's it. That's all I have. Good luck.